Alrighty. So we already looked at this. We're trying to figure out how to do number 10, or how to find the 10th term. How did we find that 10th term? What was one of the methods that you guys used to find it? Devin? You drew the 10th figure, right? You saw that this had 1 here, this had 2, this had 3, this had 4. And so if we were to find that 10th, we would just go to where we had 10, right? This would be 10. And so then what would be next to it then? If that's 10, what would this bar here be? 9, right? And then this would be 8, yeah, okay, 7, 6, 5, 4, 3, 2, 1. And then we add up all of these numbers together. Easy enough, right? Okay, so we do 1 plus, so we end up with 1 plus 2, which is 3, plus 3, which is 6, which plus 4 is 10, plus 5 is 15. And actually, you know what I'm doing? I'm kind of building a table here. So why don't I actually just build the table? All right? So what I'll do here is I'll build my table out. Okay, here's my figure 1. Here's what my figure is. Figure. So at figure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at figure 1, I will have 1 dot, right? Figure 2 will have 1 plus 2, which is 3. Plus 3 is 6. Plus 4 is 10. Plus 5 is 15. Plus 6 is 21. Plus 7 is 28. Plus 8 is, what was that, 36. Plus 9 is 45. Plus 10 is 55. So I'm going to end up with how many blocks will be there? I will have 55. Okay? Does that make sense? Blocks. So what I want to do here is I want to talk about one of the ways that we begin to analyze our functions here. All right? And one of the ways that we can analyze our functions is you guys know before, like, when we were trying to figure out if this was an arithmetic or geometric function, we would start to look at the difference between our block numbers, right? And I would look here, and I would see that my difference, we'll call this the first difference. First difference. When I look here, what's the difference between 1 and 3? 2. Okay. What's the difference between 3 and 6? 3. 6 and 10? 5. And we begin to actually see a pattern in our differences. Right? Now, this is not an arithmetic function. It's not going up by a common difference, right? Remember, like when we're talking about arithmetic or linear functions, it's a common difference. It would be plus like 2 each step. And that's not what's happening here. We're getting plus 2, plus 3, plus 4, plus 5. And so that's not really the pattern that we're used to. It's also not geometric. Remember, for geometric, we'd be multiplying each time by a similar number. We'd have a common ratio. Okay? So what is this? Well, this is something different. Okay? This is called a quadratic. And check out what happens. So we did the first difference. You know what I want to do? I want to do the second difference. Let's see the difference of our differences. Okay? Does that make sense? So we did the first difference where we were looking at the differences between our blocks. Let's do a second difference where we look at the difference of our differences. So the difference between 2 and 3 is 1. 3 and 4 is 1. 4 and 5 is 1. And you guys can see this. We're going to have a common second difference of 1. And when we have this common second difference, this is, here, let's do 3 exclamation points, because this is the real deal Homefield. 3 exclamation points. This tells us that we do in fact have a quadratic. You're very excited. Maybe I should do 4 exclamation points just to show how excited we are about having this sort of function. Okay, so this is something where at first look, maybe it didn't have a pattern we recognized, but when we take that second difference, we see this. This is going to be a pattern we're going to see again. Now, the second difference doesn't have to be 1. That second difference could have been 2 or 3 or 4 or 5. It doesn't matter what it was. But the fact that we have a common second difference informs us that it's a quadratic. Okay? Yeah?
Will there ever be common third differences?
Yes, there will be. Not in our studies, though. Okay? So sweet. So we've looked at this. I want to show you guys one more thing, too. I want to go back a little bit to kind of help us with that number 3, because number 3 is going to ask us to write an equation. So I want to show you some things. So let's look at our fourth figure. Now, what would happen if I were to flip this on itself, so to speak, right? You guys kind of see how it's like a negative space of itself? Whereas I could easily draw, and I'll do it in a different color too. Like if I were to draw in here, it's like a reflection, yeah. Right? It's kind of like it's been drawn in on itself here. Okay? We've got 4, 3, 2, and 1. And then we got 4, 3, 2, and 1. You guys kind of like how I kind of like, what was that?
I hate Tetris.
You hate Tetris? Really? Oh man, Tetris is one of the most fun games ever. The best thing to come out of the Cold War. Russian computer scientists with nothing else to do made a video game called Tetris, and it's phenomenal. It's great. All right, so you guys kind of see how it flips on top of itself here? And so we could figure out the area, right? We know that it's 4 tall times 5. So we'd have 4 times 5 and then divide it by 2. And that's one way that we could figure out how many are there, right? Because 4 times 5 is 20. But we only want half of our thing. So we get 10. And sure enough, we already knew that. We knew that it was 10 right down here. So that's one way that we can start to build our equations too, without knowing what step we're on, right? Because for whatever figure I'm on, well, that's this number. I've built a rectangle, so this number n. So if I had my squares, and I don't know how many I have, I'm just going to do something like this. It's some unknown number, but this is my step number. How long is my length going to be? If this is n, and this was 4, how long is my length here going to be? N plus 1. Absolutely. So I know that for any step number, my area is going to be n times n plus 1. Because that's going to be my length times my width, but I'm going to divide it by 2 because I'm only interested in half of it. So that's one way of doing it. So with all that information, and I'm sure you guys frantically wrote this down. And if you didn't frantically write it down, that's why I'm recording it, so that you can double check it later. Answer number 3. So it says, examine the sequence of figures and find a rule or formula for the number of tiles in any figure of number. So we're trying to find an f of n now. If we're trying to find f of n. What sort of equation can you guys come up with? I'm going to go ahead and give you guys time to do that.